Welcome to Spring LIB.
Hello. Today we're working on a problem where we have a simple pendulum that is slowly winding down and losing energy. What we're looking at for this one is that initially we have an angle for this pendulum of 11 degrees, and after 10 and a half swings, we have an angle of 4.5 degrees. We're asked to find what the loss in energy is. So the first thing that we want to do is we want to get an expression for D right here. And to do that, we just have to do a little simple geometry. And you can see that D is going to be equal to the length minus the length times the cosine of theta. And that's how you're going to be able to tell what D is. So the next thing we're going to do is we're going to look at energy conservation. So we can say that potential energy is going to be equal to the mass times gravitational constant times this D, this length. We'll call D0 what it is initially, and we'll call dF what it is finally. So when you plug this in, this is going to be equal to 0.65 joules. And when you plug in the same value, or rather the value for the final theta, you get m times g times d final. And that's going to be equal to 0.11 joules. So what we're doing here is we're just saying the difference in energy is going to be the difference in the potential energy due to the change in height. Because later on, when this theta is smaller, this d is also going to be smaller. So we can use this to find the difference in energy. And this is just going to be 0.54 joules. When using this energy, we don't have to consider kinetic energy because at the end of these swings, when they're at the very farthest side, their velocity is 0. And we can say, where did this 0.54 joules go? And we can look at it, the main place that it's going to go is into air resistance and into friction in the rope, in the pivot of the rope. So this mass is going to be moving the air, and it moving the air is going to take from its own velocity. And then the friction in the pivot is also going to remove some of that energy. So that's how you go about working on this problem. I hope this helped.